Hello everyone. Welcome to switispeaks official YouTube channel. My name is Sweetie Pinjani. This is UVM basic series where we are covering the basic UVM concepts. In case you have not gone through the previous lectures in the series, please go through. Reason is this is a continuation. In order to understand this, you should understand what we discussed earlier, especially things like what are UVM components, what is UVM test bench architecture, what is driver, what is monitor. You should understand these things. And then if you understand those things and come here, it will be easier for you to understand this UVM sequencer. Today we are going to cover UVM sequencer in detail. UVM sequencer is one of the components in UVM test bench. Let's understand about this component. First, what we should understand, what is a UVM sequencer? UVM sequencer is a component which will generate sequences for the driver. If you remember, in the tutorial for driver, UVM driver, we had discussed that driver is a component which drives the DUT. It means driver is a component which provides inputs to the DUT. And from where the driver is getting these inputs, the driver is getting these inputs from the sequencer. The inputs which driver gets are in the form of transactions which are received from the sequencer. And then the driver converts these transactions into pin wiggles, or you can say the DUT signals which are sent to the DUT. This we had discussed in UVM driver. In case you have not gone through, you can go through. The UVM driver is also available in the same series, which is UVM basics, uploaded on Sweetie Speaks official YouTube channel by Sweetie Pinjani. You need to understand that this sequencer has two parameters. One is request and response. The interesting thing here is that request is a mandatory parameter and response is not a mandatory parameter. However, request you should give. Another important thing to understand is that request and response are objects. They are not components. Sequencer is a component and the parameters which are passed to the sequencer, which is request and response, are objects of type sequence item. We are going to learn about sequence item in detail in the upcoming lectures in this series. For now, remember that sequencer has two parameters. One is request, one is response. And request is mandatory, response is optional. What is the main purpose of UVM sequencer? I already told you it has to generate the transaction and send that transaction to the driver. And later on, the driver is going to convert this transaction into the pin wiggles which are understandable by the DUT and drive the DUT. Another important point is that the sequencer acts as a mediator between the sequence and driver. Actual transaction is generated in the sequence. However, you are providing to the driver using sequencer. With the help of diagram, I am going to show you how the sequencer acts as a mediator between sequence and driver. For now, remember that sequencer driver. This is how the sequence item is going to flow. Now, let's understand the class hierarchy of the sequencer. You are going to create a user defined sequencer. I am naming it as user sequencer. This going to extend your UVM sequencer, which has two parameters. One is request, one is response. UVM sequencer is an inbuilt class in UVM which takes two parameters, request and response. And it has an export. What is export? This we are going to cover in detail in the upcoming sessions. For now, just remember that sequencer has an export. And that export is UVM sequence item pull IMP. And it can have parameters. This is the export. And then it has some functions, stop sequences, item done, get next item, put. So these two are functions, stop sequences and item done, and these three are tasks. We are going to discuss in detail about these various functions and tasks. For now, just remember these are some of the functions and tasks provided inside an inbuilt class UVM sequencer. That's why these functions are also inbuilt, which we can use. This UVM sequencer class in turn is extended from UVM sequencer param base. Even this UVM sequencer param base is taking two parameters, request and response. Again, it has some functions which we use. Send request, get num of last request, get num of last response. These are some inbuilt functions in your UVM sequencer param base. Then this UVM sequencer param base is in turn extending from UVM sequencer base. This does not have any parameters. UVM sequencer base class doesn't have any parameters. Only UVM sequencer and UVM sequencer param base have the request and response as parameters. That's why your user sequencer will also have request and response as the parameters. Next thing you should understand is this UVM sequencer base class also has some functions and tasks which we use. The functions are start phase sequence, stop phase sequence, then we have set arbitration. These are the functions. Then we also have some tasks. Tasks are wait for item done. Then there is execute item. There is a task grab and a task lock. This UVM sequencer base extends from UVM component, which in turn extends from UVM report object, that in turn extends from UVM object, which in turn extends from UVM void. This is the class hierarchy. When you are creating a user sequencer, this is what is you are going to extend from the UVM sequencer, but inbuilt inside UVM, this is how the class hierarchy is implemented. The main thing is you should remember some of the important functions and tasks which we are going to use a lot. And that's why I'm going to explain you these important functions and tasks. Let us see some of the important functions and tasks which we discussed inside UVM sequencer. Before that, we will see how this UVM sequencer is declared inside UVM. It's inbuilt inside UVM, but if we understand the declaration, it is easier for us. As I said, I focus on in-depth knowledge. That's why I try to understand, even if the class is inbuilt in UVM, at least what is the class declaration. Today I am going to show you the class declaration for UVM sequencer. This is how it is. Class UVM sequencer, as I said, it takes two parameters. One is request and it will be of type sequence item. What is sequence item? We are going to discuss in the upcoming lectures. Then there is a response, and response and request are usually of same type. This in turn extends from UVM sequencer param base, which also has two parameters, request and response. This is the declaration for the inbuilt class UVM sequencer, which takes two parameters, request and response. Now let us understand some of the important methods. Methods means there will be some functions and some tasks which we had seen in the class hierarchy. Let's understand these. We had stop sequences. When you call this method stop sequences, it will kill all the sequences as well as the child sequences and the child sequences which are currently operating on your sequence. All of them will be killed because this is stop sequences. It means you have to stop the sequences as well as child sequences both. In addition to this, it also removes all request locks or responses that are currently queued for that particular sequencer. You are killing all the sequences and you are also removing the request, locks, responses, everything you are removing when you are calling stop sequence because you don't want anything which is related to sequence. Then the next thing is item done. This is an indication that your request has completed. Then you have get. Get is going to retrieve the next available item from the sequence. Remember, sequencer is getting the transactions which are in the form of sequence item from the sequence. If you want to get the items from the sequence using the sequencer, you will call get. One important thing to notice, it's a non-blocking call. What do I mean by non-blocking call? You are using the get to retrieve the next item from the sequence. Until the next item is not retrieved, it doesn't block any processes. You can still continue with the other processes. It doesn't keep on waiting until the item is retrieved. You can proceed. This is the meaning of the non-blocking call. Then we have get next item. This also retrieves the next available item from sequence. The important question is what is the difference between these two then? The main difference is get is non-blocking, but get next item is blocking. Until you don't retrieve the next item from the sequence, your further processes are blocked in terms of get next item. However, this is not the case with get. You need to remember these differences between get and next item. It can be a trick question. What is the difference between get and get next item? The answer is clear. Get is non-blocking, get next item is blocking. This is the main difference. Then we have put. Put is going to send back a response to the sequence that has issued the request. Put means you are going to put something. You get request. Here you are getting the request. Then what are you going to send back? Response. That is what the put does. Next, we will understand about the inbuilt class UVM Sequencer param base. This also takes two parameters, request and response. First, let's understand the declaration. As I said, UVM Sequencer param base also takes two parameters. One is request and one is response. Again, the type of the request and response is usually the same. If you see here, this is how it is declared in the UVM library. And this UVM sequencer param base in turn extends UVM sequencer base. This also we had seen in the class hierarchy diagram. Let's understand the methods inside this. We had send request. This will send a request. And this function can only be called after a wait for grant call. Once you get grant, only then you can send the request. Until and unless you don't get the grant signal, you can't send the request. These are the basics. You need a grant, only then you can send the request. Then get num of last request. It will set the size of last request buffer because the size of last request buffer will indicate the num of last request, number of last request. Then get num of last response. It will return the number of responses received by the sequencer so far. Then we had a UVM sequencer base class. Remember, this doesn't have any parameters. This is the declaration: UVM sequencer base extends from UVM component. What are important methods? First was start phase sequence. This method is going to start the default sequence for this phase, if any. Whatever phase you are in, if there is a default sequence for that phase, it will start. And stop phase sequence, it will stop the default sequence for this phase if at all that default sequence is present and it is still running. If it is still running, it is present, then it will stop. Then set arbitration. It returns the current arbitration mode set for that sequencer. So whatever is the current arbitration mode, how the arbitration is happening, that information you are going to have using set arbitration. Then you have wait for item done. Item done, we had seen it indicates that the current request has completed. Once the request has completed, this wait for item done is going to wait until it receives the item done. This is wait for item done. And then execute item, what it does, it executes the given transaction item directly on the sequencer. Whatever is the transaction item, it's directly going to be executed on the sequencer. Then we have grab. What does grab do? It requests a lock for sequence specified by sequence pointer. Wherever your sequence pointer is currently, it indicates which sequence you are in. If you want to lock that particular sequence, you can use grab. When you are using grab, this lock request is going to be put at the front of arbitration queue. It means whatever things are there in the queue, they are going to execute later. First, your this lock request is going to be executed. Only then the other things in the arbitration queue will get executed. Then there is lock. Lock also does the same thing. It requests a lock for the sequence specified by the sequence pointer. Then what is the main difference between grab and lock? Main difference is grab will put the request at the front of arbitration queue, but lock is going to put the request at the back of arbitration queue. This you need to remember. The major difference, and it can also be a trick question: when to use grab, when to use lock. If you want your request to be put at the front of the arbitration queue, then use grab. If you are looking for putting your request at the back of arbitration queue, then you need to use lock. Now let us understand how your transaction is flowing from the sequence to driver. If you remember, I told sequencer is acting as a mediator between your sequence and driver. The actual transactions are coming from the sequence. Now let's understand how. You have a sequence. This sequence is going to have a lot of sequence items. Now, this sequence items present inside your sequence are going to the sequencer. From sequence, the sequence item is going to your sequencer. And from sequencer, this sequence item is going to the driver. This is how the flow is from sequence to the driver. How the transaction is flowing from sequence to driver in the form of sequence item. What are the various steps to code your sequencer? First, you need to create a user-defined class which will extend from UVM Sequencer. UVM sequencer is a inbuilt class. If you remember, UVM sequencer is inbuilt class with two parameters, request and response, out of which request is mandatory and response is optional. Then you need to parameterize this class with request and response. Request is mandatory, response is optional. Register this class with the UVM factory. We had discussed UVM factory in detail. In case you have not gone through, please go through that lecture on UVM factory. It is uploaded on Sweetie Speaks official YouTube channel by Sweetie Pinjani in the same series, which is UVM Basics. This is the third step. Then fourth step is you need to call the constructor new. Let's see this code now. First, you have a Sweetie sequencer which is derived from UVM sequencer. And the first step was to create a user defined class. You see, Sweetie sequencer is a user defined class which extends from UVM sequencer. And here I am only passing request. I told you response is optional. I am only passing request which is data item. In my case, the name of the request is data item. Then the second step was you need to parameterize the class. Here you saw I parameterized the class. I passed only request. I did not pass response. Response was optional. Then I am registering the sequencer with UVM factory using UVM component utils. Remember, I have told you for component we have UVM component utils and you are passing the name of your sequencer. This will register your sequencer with the factory. Next, you are going to call the constructor new. In case of components, the constructor takes two arguments. One is name, one is parent. Then you are calling super.new. Super means it is extending from UVM sequencer. So it will call the new method of the UVM sequencer. That's it. And that's the end of class. This is very basic UVM sequencer. You can have lot of other code however required, but this I am telling you what are the mandatory steps. Now you need to understand one very important concept. This many people ask, what is M sequencer and what is P sequencer? These are the sequencer handles. Now what is a handle? It's an OOPS concept. We had covered this handle concept in detail in System Verilog OOPS series. In case you have not gone through, please go through. There is a System Verilog OOPS series uploaded in Sweetie Speaks official YouTube channel by Sweetie Pinjani. There you will understand what is a handle. And this M sequencer and P sequencer are type of handle. What is M sequencer? It is a default handle which is available in the sequence. By default, this handle is available. And it has the type of UVM sequencer base. UVM sequencer base is an inbuilt class in UVM. This is the type of M sequencer. It acts as a reference handle to the sequencer on which your sequence is currently running. Whatever your sequence is currently running, the reference handle will be M sequencer because it is default. Then there is a start method. What this start method does, it will run the sequence on the sequencer. Sequence runs on the sequencer. And sequencer passes the sequence items received from the sequence to the driver. But sequence is going to run on the sequencer only. When you call start method, then the sequence is going to run on the sequencer. And it also provides a sequencer handle. Start method does two things. It runs the sequence on the sequencer and it provides a sequencer handle. And here is an example. You have base request dot start. You are calling start. It means it is going to run your sequencer, run the sequence on your sequencer. This is your sequence, base sequence, and this is your sequencer, sweetie env.sequencer. Start method is going to run your base sequence on your sequencer switispeaks.sequencer. Here M sequencer is the default handle. M sequencer is the handle for the base sequence. It is handle for the sequence. Remember, M sequencer and P sequencer are sequences for handles for sequence, right? So in this case, base sequence is your sequence. That's why M sequencer is the handle for base sequence. And this base sequence is running on what? Sweetie env dot sequencer. This is about M sequencer. Now let's understand about P sequencer. I told you M sequencer is default. However, P sequencer is not the default handle. It is not going to be defined automatically. You need to define the P sequencer using a macro. This macro is provided by UVM. UVM declare P sequencer and whatever is your sequencer name. For this particular sequencer, I am declaring a P sequencer. This is the meaning of the macro. This macro is provided by UVM, but you need to create the P sequencer using this macro for a particular sequencer. Here is an example. You need to define this UVM declare P sequencer, right? UVM declare P sequencer, you are passing the sequencer, and here say your sequencer name is P sequencer. You have the virtual void m set P sequencer. This is the function. The return type is void. And this is the name of function m set P sequencer. What this function is doing, it is calling super.msetPsequencer. And then you are casting the M sequencer to P sequencer. Why? By default, the handle is M sequencer. But for your sequencer, you want P sequencer. So you are going to cast using $cast. P sequencer, M sequencer. And then if the cast doesn't succeed, you are going to give an error. We had seen about different reporting mechanisms in UVM. There is a tutorial UVM reporting available in the same series UVM Basics uploaded on Sweetie Speaks official YouTube channel by Sweetie Pinjani. There we had discussed about UVM Fatal, what arguments it takes. If you have not gone through, go through. Here this is the name of my error, P sequencer error, and then this is the message which I am printing if the cast fails. And then the explanation is P sequencer macro declares P sequencer handle of sequencer type. This is the sequencer type. And cast M sequencer handle to P sequencer. Here we had seen it cast the M sequencer handle to P sequencer using $cast. And if it doesn't succeed, it will give an error. Important point to remember, P sequencer is not default. You need to define it using the macro UVM declare P sequencer. If you have seen it here, and using $cast, you can cast your M sequencer to P sequencer. Let's understand the summary now. We had seen the main purpose of sequencer was to generate the transaction and send it to the driver. This driver will then drive the design inputs. What were the methods? Now we had seen UVM sequencer was one class in which you had stop sequences, which will stop all the sequences and child sequences for that particular sequencer. Item done is going to tell that the current request is completed. Get is going to retrieve the next item, but it's non-blocking. And get next item is going to retrieve the next item and it is blocking call. Then put is going to put the responses. Next, we saw a class UVM Sequencer param base. These has methods send request to send the request. Remember, the send request is going to wait for your grant because until you have grant, you cannot send the request. Then it has get num of last request, which gets the number of last request. Get num of last response gets the number of responses received by sequencer up till now. Next, we had a class UVM Sequencer base. It has method start phase sequence, which is going to start the sequences for the current phase. Then stop phase sequence is going to stop the sequence for the current phase if it is still executing. Set arbitration is going to return your arbitration mode. Wait for item done is going to wait for this item done. Execute item will execute the item on directly on the sequencer. Grab, it is going to lock, but one important thing is it is going to lock the request in the sequence, but it is going to put that lock request at the front of the queue, and this lock method is going to put that lock request at the back of the queue. This is the difference between grab and lock. Both are going to lock, but grab is going to put that request at the front of the queue. It means all the processes which were in the queue, they will execute only after that lock, and this lock puts the lock request at the back of the queue. It means first whatever is there in the queue, that is going to execute, and then your lock request. Then there are sequencer handles. There were two handles. One was M sequencer, which is default, and then there was P sequencer, which is not default. You need to define it using the macro UVM declare P sequencer and your sequencer name. Then we had seen the steps to create a UVM sequencer. You need to first create a user defined class which will extend your UVM sequencer. UVM sequencer is inbuilt class. Then you will parameterize the user defined class with request and response. Your request is mandatory, response is optional. And then you will register your sequencer with UVM factory and finally call the constructor new. This was about the UVM sequencer. In the upcoming lectures, we are going to cover a lot of other concepts in UVM. If you are interested in such content on technical content, specifically on VLSI, you can subscribe to switispeaks official YouTube channel. My name is Sweetie Pinjani. I look forward to more such content. Stay tuned and see you soon.